Hello, good morning. I am SEEMA GARG, Associate Professor in Chemistry, SPC Government College, Ajmer. Today, video 99, lecture 38. It is for B.Sc Part 1 Organic Chemistry, Paper 2, Unit 3. In continuation of arenes and aromaticity, today we will see the chemical reactions of benzene. Benzene molecule exhibits high degree of stability. It is not easily oxidized with common reagents. It prefers substitution reactions rather than addition reactions. Addition reactions. Benzene is a very stable compound and usually does not undergo any addition reactions under drastic conditions. Benzene plus 3 molecules of chlorine, it will give B.Sc, benzene hexachloride, or it name as a 666, or gamexane or indane. Addition of ozone. Ozone molecule, also we can add 3 moles of ozone, we can add to benzene and it will give benzene triozonide. On hydrolysis, it will give 2 glyoxal plus 3 molecules of water. Addition of hydrogen. 3 moles of hydrogen we can add to benzene and it will give cyclohexane. Birch reduction. It is a very useful reaction. When benzene is reduced in presence of sodium in liquid ammonia and ethanol, it will give benzene cyclohexadiene. Sorry, it is a cyclohexadiene mechanism. Benzene is when sodium give electron, then it will form this type of anion and radical form. Then again, ethanol will give one proton and it will be reduced. One carbon is reduced. Then again, sodium will give electron and then it will give this anion, and then ethanol give proton. So it will produce cyclohexadiene on reduction with, it is called Birch reduction process. Oxidation. Benzene is when subjected for oxidation in presence of vanadium pentoxide, it will give maleic anhydride, 2 moles of maleic anhydride, water and carbon dioxide. Benzene usually easily go for electrophilic substitution reactions. General pattern of mechanism. In step 1, electrophile will attack to the benzene nucleus and it is a slow step, and then it will form arenium ion, and then removal of proton from this arenium ion and it will finally give product. Difference between electrophilic substitution and electrophilic addition. When electrophilic substitution occur, that substituted product maintain the aromaticity of the benzene product. When addition reaction occur, then it will give alicyclic compound. here aromaticity of the ring is lost. So this is the basic difference between the electrophilic substitution and electrophilic addition reaction. Some examples of electrophilic substitution reaction: nitration, it will give nitrobenzene. The reagent is nitric acid and concentrated sulfuric acid, and at 50 degrees centigrade temperature it will form nitrobenzene. So in first step we will produce the nitronium ion as an electrophile, and this nitronium ion will substitute the benzene ring, and it will give finally on two steps, it will give nitrobenzene, and the reagent which we have used as a byproduct. Halogenation. Halogenation, we can do two type of here halogenation easily: bromination and chlorination. Ferric tribromide is a catalyst which we are using. Bromobenzene, first it will form electrophile, and then on hydrolysis it will remove its proton, benzene ring proton, and will give bromobenzene. Similarly, chlorobenzene we can produce with the help of ferric chloride in two steps. Sulfonation. Sulfonation we can carry it out in presence of concentrated sulfuric and oleum, means sulfur trioxide, at 30 to 50 degrees centigrade temperature. It will give benzene sulfonic acid. See here. So here also SO3, it is a electrophile, and it will attack to the benzene ring, and then HSO4 nucleophile will abstract proton, and it will form sulfuric acid. Then hydronium ion will finally give benzene sulfonic acid. Friedel-Crafts reaction, Friedel-Crafts alkylation reaction. Here benzene and aluminum chloride, Lewis acid, alkyl halides, and then it will be react and it will form alkyl benzene. This is the mechanism. Similar type of mechanism. In first step, reactophile will attack, then in second step, removal of proton of benzene. Rearrangement, when electrophilic substitution reaction occur, sometime that here rearrangement reactions are also observed. Means here it is a normal propane, and it will convert it to this isopropane molecule. It is an important cumene. Friedel-Crafts acylation reaction. Acetyl chloride in presence of aluminum chloride, it will give aceto group, and this aceto group will attack to the benzene acetophenone. Deuteration reaction. In deuteration, this D2SO4 dideuterated sulfate, instead of like it is a similar structure like sulfuric acid, but here in proton, in presence of proton, it contains deuterium ion. So we can produce deuterium benzene also electrophilic. It is an electrophilic substitution reaction. Last reaction is mercuration reaction. Mercury acetate, it will ionize to electrophile and nucleophile. This electrophile, mercury acetoxymercury electrophile will attack to the benzene, and then In second step, slowly it will release the proton, and finally we will get acetoxy-mercury benzene. So this is about the electrophilic substitution and addition reaction of benzene. So thank you very much for today's lecture.